All right, picking up right where we left off with the previous video, and like I said in class, this chapter really is a whole lot of practice. So lots of practice examples on doing the naming and coming up with formulas. So picking up where we left off, we were naming non-binary compounds. Remembering binary means there's only two elements. This one's got two by itself. This piece has two by itself, so we actually have four things altogether. So not binary. Okay, and the good thing about not binary is all we have to do is name the pieces. Okay, so the first piece, that NH4, that's the ammonium ion, NH4 plus. And the other piece, the NH3, the NO3, is the nitrate ion. So this compound is just ammonium nitrate. Okay, looking at this one. So again, not binary. And notice that we have lead. So remember, lead could be a plus 4 or a plus 2. All right, so we need to use our anion to tell us what the cation charge is. So that particular anion is NO2 minus. And I have two of them. So that subscript 2 on the outside of the parentheses tells me that I have two nitrates. Right, so that gives me two minuses, and then I only have one lead, so it needs to be a 2 plus by itself in order to balance those two minuses. So plus plus, minus minus. Right, so since it's not binary, I still just name the parts. So I have lead, and because it is one of the ones that can do multiple charges, I have to specify that it's lead 2. And NO2 minus is nitrite. Okay, NO3 is nitrate, NO2 is nitrite. Okay, so you can take a quick check on your work, see how we did. All right, continuing with writing names. So potassium is one that only makes a +1 charge, so I don't have to worry about a Roman numeral. I've got 3 elements there, so I don't use binary rules. So we have potassium, and this polyatomic, this NO3, is nitrate. That's all there is for that one. All right, here we have potassium and NO2. NO2 is the nitrite ion. And then we just give the potassium name. Right, again, noticing that we have more than 2 elements here. This piece right here, that's our ammonium. And then the Cl minus by itself is chloride. All right, now this one may look a little intimidating because there's a lot of different things going on here. But this piece right here, the C2H3O2, that's just another one of the polyatomic ions, and it's the acetate ion. Right, now zinc, even though it's a transition metal, it's one of the rare transition metals that only does one charge. It does a +2 only. So I don't need to use a Roman numeral, and I just say zinc acetate. Now this one, this OH, that's one of our polyatomic ions. That's the hydroxide ion. And then again, we have more than 2 elements here, so I just name the parts. So sodium hydroxide. Now we had a couple of these that are not binary that end in IDE. So I want to clarify that really quick before we go any further. So this IDE is kind of special in that it's simply the name for that ion. Okay, an IDE here doesn't necessarily mean that we're dealing with a binary. That just happens to be the name of the OH- ion. And coming back to this one right here with the ammonium chloride, the Cl- ion that goes with ammonium in this compound is simply called chloride. So we're not trying to be tricky, we're just kind of sticking to the rules. The Cl- ion is called chloride, the OH- ion is called hydroxide. So we're not bending the rules, we're just actually applying them very carefully. All right, 11F. So more than 2 elements. This part right here is the phosphate ion. Potassium is one that only makes a single charge, so we just list it without a Roman numeral. Potassium phosphate. And here again, we got something that looks a little bit crazy, but if you just, once you're comfortable with your polyatomics, you'll recognize that NH4, that's ammonium, and CO3 is carbonate. And that's all there is to this one. So a vast majority of the time when we're naming things that have more than 2 elements, all we have to do is just say the parts. And in fact, that's exactly what we did here. The only weird ones were this chloride and this hydroxide. But we talked about how Cl-, that ion is called chloride. So we're not doing anything special. This OH- is called hydroxide. So we're still just naming the parts. All right, so switching gears here a little bit. So instead of going from formula to name, now we're going to start going from name to formula. So the strategy here is to write the ions. With their charges. Okay, so the zinc ion, zinc 2+, and the sulfate ion, SO4 2-. Right, so a ++ for the zinc, a -- for the sulfur, or the sulfate. So they already balance each other out. So our formula, ZnSO4. All right, so ammonium sulfide. Right, so the formula for the ammonium ion with its charge is NH4+, 1+. And the sulfide ion is just S, 2-. All right, so easy way to balance these when they're not the same. So in our previous example, we had 2 and 2. So they already balanced each other, so I didn't do anything there. Here I've got a 1 and a 2. So here's where our crisscross method will come in handy. And that's a 1, goes with the sulfur. All right, because NH4, I treat that just like its own entity, so I need to put it in parentheses if I have more than one of them. And I only needed 1 sulfur, so NH4 2S. And this subscript 2 tells me that I have 2 NH4s. All right, copper 2 hydroxide, or excuse me, just oxide, okay? So that Roman numeral 2 automatically tells me what the charge of the copper is. So I have Cu2+. That's what the Roman numeral tells us, is that it's 2+. And then the oxide is just O2-. Oxide is the name for the oxygen ion. So I've got a 2 and a 2, so they already balance out, a plus and a plus, and a minus and a minus. So I just put them together, CuO. All right, aluminum nitrite. So our aluminum ion is one that only makes one ion, and it's a 3+. And then the nitrite is NO2-. All right, so I'm going to do my crisscross. All right, so I need 1 aluminum and 3 nitrites. So I'm going to see Al, and I need to put the NO2 in parentheses and say that there's 3 of them. All right, how about zinc sulfide? So we already had zinc sulfate. This time we're doing zinc sulfide. So our zinc ion is a 2+, and our sulfide is just the sulfur ion. So we've got 2 and a 2. They already balance each other out. So just ZnS. All right, so iron 3. So remember that Roman numeral 3 tells me what the charge of the iron is. It's a 3+. So Fe 3+. And nitrate is NO3-. So I'm going to take my 3 and put it with the nitrate, and my 1 put it with the iron. So I just have Fe, and I need to use parentheses because I need to say that I have 3 NO3s. That's what that outside 3 tells me, is that I have 3 of those polyatomic ions. All right, one more and then we'll call it quits on this video, okay? So copper 2, that Roman numeral 2 tells me that it's the 2+ copper. And our hydroxide ion is the OH-. So I'm going to take my 2 and put it with the hydroxide, my 1 with the copper. So I have copper, and then I have 2 hydroxides. So I put that in parentheses with the subscript 2. All right, so sitting at about 15 minutes for this video now. So we're going to go ahead and call it quits, and we'll come back right here with the next question. Have some fun.